We have a publishing session now with Tony Graham, followed by Andrew Sales. Both presentations talk about Schematron and so on and so forth. Let's start with the first one. So Tony Graham from Antenna House, please take it away.
All right, thank you, Charles. I'm working with Antenna House. I work for Antenna House Japan, and I work with Antenna House USA, but in reality I'm based just over the water in Ireland. So, oh, come on, work. Worked a minute ago. That's what you get for having the video work properly. Okay. Technology. Okay, so I'm going to start with a question, really. If I have a 28 megabyte XSL-FO file that has 198,995 elements, 711,185 attributes. And of these, the majority of the attributes can actually be parsed as expressions before we can parse their values as FO data types. And I'm using a schema that has 829 relax NG patterns, as well as 611 Schematron asserts or reports. The question is, how long do you think this would take to run in an editor on this laptop? It's not quite as old as John Lumley's, but it's 3 years old. Do we have any off-the-cuff estimates from the experts in the room, other than George?
10 seconds.
10 seconds, okay. Do I hear higher? Lower? Hour and a half?
4 days.
Okay, so somewhere between...
11 seconds. Which editor?
Well, there is only one, isn't there? Just ask George.
Part of that stack is evaluating the expressions.
That's an interesting question. So, anyone daring to go lower than 10 seconds? No? Okay. You have a PR problem, George. Or I do, one of the two. So, to begin at the beginning, as Julie Andrews might say, I didn't set out to parse a 28 megabyte file. Part of my job at Antenna House is to try and make XSL formatter easier to use. And there were some user requests for validating FO files. You might want to do this to validate the output from your transform, or when you're prototyping what you're going to format, you hand edit a file, format it to see how it works, and iteratively do this. So I demoed this at XML Prague, and I thought I was onto a good thing. And then my colleagues in Japan, they sent me this 139 kilobyte file with some stuff that didn't parse, expressions that didn't parse. So I had adjusted this FO check project and made a new release. They sent me one that was 808 kilobytes, which was their DITA test file. So I made the parser parse that properly. And then they sent me the 28 megabyte one, which they helpfully pointed out has something like 43,000 validation errors and a couple of thousand Schematron errors. So this is what they're trying to parse in the editor. These 198,000 elements, if you're not up on FO, the elements in your FO file represent your formatting objects, which are the technical term would be the typographic abstractions available to the designer. They're how you think about what you're putting on the page, and then the formatter will make the areas from that. So there's conventional ones you might think of as a block, footnote. There's one for wrapper, which is for hanging inheritable properties from in-stream foreign object. You can put your SVG inside it. Something added in XSL 1.1 is the ability to put change bars in your FO and have change bar markers appear in the formatted output. And for the 711 or so attributes, they represent the properties that you apply to these formatting objects. They're associated with an instant of a formatting object to say what it looks like. So color, font size are fairly what you'd expect. Master name is getting from your flow to the page master you're going to use. In the spirit of XML, terseness was of minimal requirement for FO as well. Relative align, another one is for aligning text across multiple table cells, etc. The thing about this is that most of these attributes can be parsed as expressions. FO has an expression language that you can use. The spec actually says all property value specification and attributes can be expressions. But whether some of the shorthands inherited from CSS are or aren't is debatable, etc. So font size 12 point is an expression. You can put in expressions that can only be worked out at the time that you're formatting, things based on the font size or things that are based on a percentage of the available width. Only the formatter really knows at the time what it is. And there's convenience functions that you can use that are defined in the FO spec for getting things from the area tree or from the elsewhere in the FO document. So for this user requirement, I wanted to make a schema. I used RelaxNG. I've written this in the RelaxNG compact syntax because it's easier to write and because the models as they're expressed in the XSL 1.1 spec are very close to the RelaxNG syntax. So it was easy to convert from one to the other. And since I'm writing RelaxNG for the antenna house extensions, it's just personally easy to write this in the compact syntax. And this is translated using Trang, yeah, to the XML syntax for RelaxNG for use with Oxygen. And the day that Antenna House announced this on their user mailing list, within hours someone wrote back and said, can you do it in W3C XML schema? Because they used a different editor. So again, using Trang, we translated into W3C XML schema. I've neglected to mention that you can run this standalone using AMP tasks that are also available. The proper reference there would be render unto Caesar, but at this point we're not rendering, we're just validating. We're using RelaxNG for what it's good for, which is checking the element structure, checking that the required attributes are there. Some of the FO data types map straight to ID and ID reference. And we're checking the value of the XML lang attribute, which is defined by the RFC. And then all of the other attributes are just treated as optional and containing text because you're leaving that to the Schematron to check. So the RelaxNG, there's the core module, which is the one for the XSL-FO formatting objects and their properties. And another little thing about XSL-FO is that inherited properties can be used on any formatting object, and their values will be inherited by the formatting objects can actually use them. So in practice, you could put all of your inherited properties on the FO root, the document element for your FO file, and they'd be used where appropriate. And Antenna House, some of their extensions are inherited, so they can also be used on any element. And then lastly, there's the Antenna House FOs and properties, which are stuff that are written by hand for the particular extensions from Antenna House. But the thing is, I'm supposed to be standing here making it sound like I've done a whole lot of work, but I'm fundamentally lazy, and the majority of this is actually generated from the XSL 1.1 spec. The XSL 1.1 is available as an XML document, and as you can see, it provides content models which are easy to parse, and you can follow the references to find what these inline and block FO or these element groups are. They look just like parameter entities in a DTD. So this seems pretty simple. You can generate the RelaxNG fairly simple. We make a pattern for the model. You can see the resemblance to what we had before. We can find the appropriate elements. But, the first but is there's a whole bunch of other formatting objects which are considered to be the neutral ones you can use practically anywhere. And they're not, they're obviously not appearing in the content model as defined. There's another but. There's XSL 1.1 added this change bar begin and change bar end, which are considered point formatting objects, which are allowed practically anywhere inside a FO flow or FO static content. And the third one, just to make things interesting, there's some so-called out-of-line formatting objects, which are allowed practically anywhere except where they're not. They can't be a descendant of any other out-of-line formatting object. So you can't put a float inside a float. You also can't put a footnote inside a footnote. So the generated RelaxNG gets a bit more complex. The part up there in green is generated from the text of the XSL spec as well, but it's a documentation comment that ends up in your Oxygen as a tooltip. And this is what that simple text or inline or block turned into. We have the neutrals, but we can also have the out of lines, and then anywhere at all we can have the points. Generating the attributes is pretty simple. It's following the links within the document. Some of these are defined as groups of properties, and some are, a whole group of properties will apply to a particular formatting object, and then there's a list of individual properties that will apply. We'll look at another FO wrapper. This one sounds pretty simple. FO wrapper formatting object is used to specify inherited properties for a group of formatting objects. You just use it to hang inherited properties or an ID attribute off. But it's only permitted to have children that would be permitted to be children of the parent of the FO wrapper. So in a block context, an FO wrapper can only contain what's allowed inside a block. In an inline context, it can only contain what's allowed inside an inline. So the RelaxNG, unlike a DTD, for example, you can define the same element name more than once. So in the inline context, we're using an FO wrapper block with a different model, and an inline block context, we're using a different one. And that which brings us to the Schematron. So far with the RelaxNG, we've tested the structure as best we can, and then there's the Schematron. Schematron, sort of like the RelaxNG, is written in multiple stages. There's a module for the FO structural rules. The examples I've shown you have only just begun to scratch the surface of the exceptions and caveats in the XSL spec for what is and isn't allowed. There's an auto-generated model for checking the property values, and there's another module handwritten for the antenna house extensions. So for auto-generating the properties of the Schematron for a particular property, this is from the XSL spec. The column count property can be a number, which is a defined FO data type, or the keyword inherit. And from that, we generate all of this. Apart from the comments, it's when we're in a column count element on a FO element, because naturally I found that some of the FO property names correspond to ones in SVG, and I started validating SVG attributes as if they were FO, and it just didn't work. We're testing whether it's a number or an enumeration token, which is basically an NM token, which is what inherit looks like, or an error or an object. Sometimes there's syntax errors in the original XML, and object, some of the functions that are defined in the XSL spec aren't quite fully implemented in FO check, so I just make a object, because I'm not going to do the calculations that the FO processor would do to find the right result. So if it's not that, then we get a search, we get something showing up in Oxygen or from the Schematron output. And the only allowed enumeration token is inherit. And we also handle syntax errors, like if they put in a length there instead of a number, or if they just put in some sort of gobbledygook. So that's for the value after it's been evaluated. So hopefully, no, yes, no. The interesting, that is hot. So that is now bold. The interesting part here for evaluating expressions is something called parser runner. The expression evaluation happens with a parser that's written in XSLT. It's not actually written in XSLT, it's just generated as XSLT using the Rex parser generator. So this is part of the eBNF that gets fed to Rex to produce an XSLT, a whole bunch of XSLT functions that you can feed in a string and you'll get back the parse tree from it. So this is taken from the productions in the XSL 1.1 spec itself, except I've had to add some of the extra unit types that Antenna House supports. There's more eBNF below that in the real file. So parser that we generate from Rex produces a parse tree. So what does -1, -2 produce? It produces all of this, expression, element containing EXPR containing an additive expression. If you went back to the EBF, you could follow through to see how it arrived at this. But this isn't exactly an FO data type, is it? So there's the XSLT function that's called for the parser runner reduces this to a FO data type. It's implemented using only XSL function because I tried running XSL template and apply templates on the returned result. But for some reason, when there was an error, Oxygen was reporting the error location as being inside the XSLT for the expression parser, not for the source document. I think it's from where it was picking up the context for the XSL message that created the whole thing. So we saw earlier some of the Schematron that was generated just to check the evaluated the result of the expression, but there's lots of other conditions that you need to express. Some of these are to do with the structure. A footnote cannot be a descendant of a float or a footnote. A footnote cannot be a descendant of a block container that generates an absolutely positioned area. So an absolutely positioned area is an area that has a fixed position on the page rather than being in the flow of the text. And similarly, it can't contain a block container that generates an absolutely positioned area. Because what does it mean if you have a footnote that could be anywhere, but you want to put an absolutely positioned area related to it? And it can't have a float, footnote, or a marker as a descendant. Okay, 5 minutes. Similarly, there's some more hand-generated schematron for some of the other constraints in the spec. The key thing, as someone mentioned, is how often are these evaluated? When you've seen one point, you've seen them all. This isn't a reference to Ireland's Eurovision success. It's the thing, thanks to the Saxon MIMO function, which is available in Saxon EE and PE, and that's what Oxygen uses internally. When the schematron sees one of these expressions, it gets evaluated once, and then the result is reused rather than evaluating it all again and again and again, because there's lots of 12 points, lots of autos, lots of inherits. But this is fairly complex, so of course there's some testing that goes on. I use XSpec for testing the parser runner and testing the schematron that runs all of this. I use STF, which schematron testing framework, which I wrote in an earlier previous life. That you make some sample XML you want to run through your schematron, and the STF processing instruction tells you what errors what you expect to see, and it checks that you have only the ones that you expect to see and none that you don't expect to see. So how long does it take to run in the editor? That's the question. Anyone want to revise their estimates?
Has it been running for the whole talk?
I was going to use that line, but well, Oxygen has been running for the whole talk because, but has it?
My estimate to more than 10 seconds.
More than 10 seconds. Okay. Well, we're all deferring to Michael K. Is that it?
I'll go for 4 seconds.
4 seconds. Oh, I like you.
I'll say 40.
Somewhere between more than 10, 4 and 40. Okay. Okay, so over here, the Oxygen has this information window that gives you. I can pin this, can't I? Yes. Right. Oh, come on. Okay, that's 7 seconds. That's what I expected. There we go. You're all wrong. That's not currently at 4 seconds, but there are ways. There could be ways to make it faster, but.
Well, it stops when it finds a problem. I mean, you only know when
No, it doesn't.
when there's no problem, right?
Well, no, because you saw the second slide that showed 43,000 errors in there. If it has errors, it actually does slow down because the I/O of producing this is much quicker. It's much slower than something that runs straight through and doesn't produce anything. So, in summary, FO check is available on GitHub. You can use it as an Oxygen. You can actually download the Oxygen add-on straight from GitHub into your Oxygen. There's also ANT targets for running it from the command line. It's available in 2 flavors of RelaxNG and W3C XML schema, as well as the Schematron. It handles XSL 1.1. Some of the FOs and properties are added that you won't find in previous schemas for FO. And it runs quicker than all of you except for Jim expect. So, thank you. So, any questions?
It sounds like a very interesting tool currently targeted at FO, right?
Yes.
It also looks like a tool you could use for any other XML-based grammar.
Well, yes.
Extending it somehow and making useful, changing it with useful error messages.
Yes. Yeah, I mean,
You mean Schematron?
No, not the schema. I mean the basis of your FO check project.
yeah.
Taking that and extending it to, well, the more general case, if there is such a thing.
Yeah, I mean, it's, what's the term? Unique selling point is the parsing the expressions. The slide I didn't think I'd have time to show is that this is all possible because computers are getting faster. The previous paper I mentioned in my paper is that the RenderX, they discuss different ways of doing this, and they talk about we could do things with XSL-T, but we can't really do it. If we at a stretch, we can do relaxing G in the schema. I mean, in the editor, and the difference is, of course, that processors, if you take Moore's law at face value, the processor is at least 10 times faster. And the fact that, well, we have Schematron and relaxing G built into the editor also makes it possible. Any more questions?
Okay, thank you. Thank you,
Thank you.
Tony.